I started out in orthopedics as an undergraduate researcher at the Beth Israel Orthopedic Research Labs in Boston. My mentor was Thomas McMahon. I did a graduate work at Stanford University. My mentors were Dennis Carter and Gary Beaupre. And then I did a postdoctoral fellowship at the Mount Sinai School of Medicine with Mitch Schaffler, and another postdoctoral fellowship at UC Berkeley in mechanical engineering with Tony Keaveney. I had great mentors in both places, but I had personal issues that needed to get me back to California after I was in New York City. So my now wife was doing medical school in California, and so that was an extra impetus to move back to California after having that postdoc experience in New York City. So what we're doing now is trying to understand how the gut microbiome influences bone and joint disease and the success of orthopedic surgeries. And what we think is that it's possible that you can manipulate the gut microbiome in a way that is beneficial for osteoporosis, osteoarthritis, and the responses that happen after orthopedic surgery. So clearly, I think mechanics is super important for orthopedics. If you stop and think about it, every single musculoskeletal disorder out there is a result of mechanical failure of the musculoskeletal tissue. You stop and think about it. Maybe you can challenge me on that one, but everything I can think about, in the end, it's about inappropriate mechanical function of the musculoskeletal tissue. So mechanics is a key component of orthopedic research, no matter what. So I think that's been really, really useful for me as I approach problems in orthopedics, that I'm able to keep that in the back of my mind when I think about translational applications for the basic science. Is at the end of the day, how is this going to improve the mechanical function of the tissue or reverse inappropriate mechanical function of the tissue? And I had earned tenure, and I was asking myself, what else is out there, and what else could we do to really change the field of orthopedic research? And I was doing lots of reading, sort of all over the place, and came across these new findings in the microbiome and how the microbiome was influencing disease processes throughout the body. And that's sort of when I realized, hey, it's probably going to be doing something to the musculoskeletal system. And I had a sabbatical leave, and I spent that sabbatical leave in a microbiome lab. And that's where I learned how to manipulate the microbiome in mice, which is our standard animal model in most of our work. And then from there, we just started applying those methods of manipulating the microbiome to just about every musculoskeletal disease model we could try. And we're still doing that, a little bit of that. I think scientifically, it's been understanding that link between the gut microbiome and the musculoskeletal tissues. And most of the people in the microbiome research community focus on the microbes themselves. So they're trying to understand the interactions between those microbes. Or maybe they look at the responses at the gut lining. So they're immunologists, but their interest stops at the lining of the gut. But we see these phenotypes in the musculoskeletal system, in the bones and joints. And so trying to explain how, or figure out, trying to figure out how changes in the gut microbiome influence bones and joints is hard. There's multiple potential mechanistic pathways. We can look at vitamins that the microbes produce. We can look at regulation of the immune system at the gut lining that then has effects at the bones and joints. We can look at microbial metabolites and how they might affect the bones and joints. And it's possible that any of them could be influential. And we have to go through each one at a time and figure out which is having the greatest effect on bones and joints. We just had this strange discovery. We were manipulating the microbiome in our mice to study how the microbiome influences bone tissue mechanical properties. And we had a control group. The control group was getting, you know, sort of what you would call a vehicle if you were doing a drug treatment, but we had to include this control group. And every study we'd done before then, we did a manipulation that resulted in a microbiome that impaired the bone tissue mechanical properties. But in this control group, the bone tissue mechanical properties actually got enhanced. And so suddenly it's even more exciting to us because there's a possibility. It's even more exciting to us because it means there's a possibility that we could use some kind of manipulation of the microbiome to enhance bone tissue strength. And that's something that we can't do right now with most osteoporosis drugs and pharmaceutical interventions. And so if we can do it with the microbiome, there's a lot of potential there for clinical translation. I have to say, you know, maybe one of the most memorable moments was last year. I had a student in my laboratory, Marisol Luna, and she's been into the ORS and was an ORS member. She was even interviewed for the ORS membership committee video a few years ago, and she graduated last summer, and then put up a post on LinkedIn telling everybody that she was the first Latina to earn a mechanical engineering PhD at Cornell. Cornell's mechanical engineering program has been around for 150 years. And I was just super proud of her and super excited to see what she's been able to do and the barriers she's been able to break. So that was extremely rewarding. Oh yeah, I do whatever my kids are doing these days. So I've learned more about fishing in the last 2 years than I ever knew before, and picking up whatever sports they like to play and whatever other things they like to do around town. And so I do spend most of my time with the kids. Whatever it is they like to do, I try and pick it up. It's just finding a good home and finding something you're passionate about as a graduate student, and just let things go from there, and feel free to explore. The things that are exciting, that might seem scientifically exciting really right now, may not be as scientifically exciting in 5 or 6 years. And so you have to be open to hearing what new things are coming and what new changes are happening in science even during graduate school. So the ORS has supported me sort of throughout my career. I've been involved in the ORS since I was an undergraduate practically. And it just provides this home that's unique because there are engineers and there are biologists and there are clinicians. And as an engineer doing medical research, it's really, really nice to have that direct connection to the biologists and to the clinicians. And it keeps us from getting lost in esoteric engineering problems, because at the end of the day, we have to address the clinical problems.